Hello everyone, this is Dr. E, and for today I'm going to share with you how I teach my students solving limit of a function both graphically and analytically, and why is it important to master some of our algebra fundamentals in working with calculus problems similar to finding the limit of a function. And yes, calculus can be a little bit daunting and can be intimidating for most students, especially when they start working with problems involving limit of a function, because sometimes it can be confusing because of the notations that they are seeing. Seeing an unfamiliar notation like the limit notation can throw a lot of students off. So to be able to make our students more comfortable with working with problems involving limit of a function or calculating or finding the limit of a function, we need to make sure that they are understanding the reason behind the use of factoring, conjugate, simplifying complex fractions when we are answering problems involving the limit of a function. And this is what I'm going to be sharing with you. And if you're a student and want to see more examples on how to solve limits using a graph or using the factoring technique or the different techniques that we are using in solving the limit of a function, it's in the description box below, and you can use them and answer problems that I am sharing with you on those videos. And for teachers, you can free to use all these videos that we have. We have playlist here for finding limit of a function that all of you can share to your students. And the first thing that I always share or practice to ease in or to help my students ease into the topic of solving for the limit is reviewing their skill on factoring, the different factoring techniques in algebra, and rationalizing rational expressions by its conjugate or by radical expressions. And also, I haven't added it, or I forgot to add it in the list, simplifying complex fractions. So those are the three skills that I usually prepare my students before they work on problems involving limit of a function that needs to be solved algebraically or analytically. So before we move on to a more challenging approach on answering limit of a function, I always start with making sure that my students are understanding how to solve the limit of a function graphically, because knowing how to solve limits in terms of graph will help students understand why sometimes limit exists and why sometimes limit does not exist. And it's not just an abstract concept that they are memorizing or just going through the motion of writing D and E, because after they have factored the rational expression and substituted the value of x in the limit function, the denominator is 0. So more than that indicator, students needs to know why it is happening like so in terms of a graph. So make sure your students are understanding how to solve limit of a function graphically, so that when we start working with solving limit of a function analytically, it will be a lot easier for them to understand why sometimes limit does not exist. And this is what I'm going to be sharing with you. I'm going to be sharing with you a graph of a function, a piecewise defined function, and this is a perfect way on how we can help our students understand limit using an algebra problem and using a calculus problem. So they would know the difference, or they would understand it better, that when they are solving limit, they are basically just looking for the value of y given the value of x. So for problem number 1, this is just an algebra problem, and we know that if we're looking for f of -1, we need to know what the value of y if x is equal to -1. And x is equal to -1, and we have two possible answers. It could be this value of y, which is 1, or this value of y, which is 0. But we know in algebra, if the graph has a hole in it, that means it does not exist. So the one that we're going to be using will be the one that exists, which is at y equal to 1. And when we translate this to a problem involving limit, notice that it's pretty much a little bit similar to problem number 1, but this time we're talking about limit, and limit is when, pretty simple, when the value of your function exists coming from the left and coming from the right. So in this case, so we have two directions coming from here, coming from the positive side of our function, and coming from here to the negative side of our function. And we can see that coming from here, the value of our f of x is at x or y is equal to 1, but coming from here, the value of our f of x is now at 0. So that means we can tell them that this limit does not exist because basically it defies the definition of a limit. And testing them with f of negative 3, f of negative 3 is somewhere here, and we know that it's just f of negative 3, or simply the function, and the value of y at x is equal to negative 3, and the value of y at x is equal to negative 3 is at 0. But if we talk about limit, just like what they know, coming from this direction and coming from the negative direction, the function is approaching the same value of y. Therefore, the limit exists and it's still at 0. So this is why we need to understand how finding or solving for the limit graphically can help all of us to understand how we're going to be answering problem similar to this one, problem number 5, because this is when we will use factoring in solving for the limit. And because f of x is no longer this f of x, but this specific new function right here, so we're not seeing the graph anymore. So when the graph is not shown, that means our next resort will be solving it analytically, either by factoring, simplifying complex fractions, and other algebra techniques that we can use. And we know that this function by substitution method will not exist, but using factoring, x plus 1, x minus 1, all over x minus 1, we know that this limit will exist at y is equal to 2. And this is how I introduce the value of understanding limit graphically before we move on to learning how to solve the limit analytically. So 3 things. 1, they need to master their factoring techniques and their simplifying of complex fractions in algebra, and then making sure that students are understanding how to solve limit graphically, so that when they work on problems, when the graph is no longer shown in the problem, they can still solve or find the value of the limit without using the calculator, using algebra, because now they are understanding how to solve limit analytically. So this is how I share or how I show my students the beauty of solving for the limit of a function. It can be too abstract for most students, especially if they are seeing problems involving limit for the first time. But if we can connect how it's related to algebra and how algebra plays an important role in answering problems involving limit, calculus, specifically learning how to solve for the limit of a function, can be fun and interesting for our students. And this is Dr. E, and see you again next time. Bye!